I guess we are live. We are live, guys. We are live. We are live. hmm so today I'm playing chess with one of my old friends. So yeah. Oh, okay. I guess it's 5-0, and I have to play fast. So this is my idea. Simply. What is this like? Okay. I would go like that. It's 3-2. It's better to take. Hmm. I would castle. Hmm. I think. Okay. Hmm. Let me just have. Okay, now he has some threat. You can take for sure. I'd love to break the chain. I don't know. He has some problems. So I'm playing with my really great friend, and now he has unpinned the knight. But yeah, okay. And here comes the problem. Hmm. I have blundered for sure. I have blundered. Yeah, I have blundered. What to do? Start the conversation. I think I should have gone here. Uh, oh wow. I do not want. Hmm. I do not have any idea what to do. I want next match to be 5+5. Okay. Hmm. Yeah, I'm just losing this one simply. Oh, we started really badly. We started really badly. Okay. Hmm. He has a passed pawn. Like, there is no way we can win this one. Okay, let me resign this one. Yeah. Uh. Haha. Fo- I want to ask him for a 5 plus 5. Uh. No. Let me ask him for a 5 plus 5. 5 plus 5. I cannot just go with this thing. Okay. Hmm. Ha. Yeah, that's a bad start for today. I didn't eat anything, so I want to eat. I need to order something. Let me just take. Let me go here. You cannot actually take. We are bad. I'm really bad in development. He might want to come here, but yeah, that is all fine. I need to have the initiative. This might be his plan. So this is his plan for sure. I would want to have the bishop here. Let me attack simply. Hmm. Currently this is not defended. I need to defend this one. So let me defend this. I have to start thinking like what is he doing with the move, right? But I am really worried about this knight. My There is. Okay, let me attack this one first. He might want to jump into the position. So hmm. The player in front of me is really good in chess, like, and I am a programmer. I do not play chess at all, so I am playing really bad in front of him. And the first game was a Doom. Uh, yeah, I don't know if I got something. Can I play with you? Hello, yes, for sure. Yes. Oh, I was not looking at the chat. Actually, I was not looking at the chat. So, what's up? Yeah, it's going nice. How are you doing? Just play chess. So I'm trying to play some chess with. I am actually bad at chess, so I'm doing it for. I do not know. Hmm. So I think I should connect my rooks. So I see his plans are like uh, pushing the pawns. So yeah. Mm-hmm. This move actually makes sense. It's an attack. What's the best move? Like this one or this one? I think I want to have some space for maneuvering bishop at some point. So yeah. Hmm. I do not want to trade bishops. I have bishop pair, but if I would not trade, I see his pawn push plan would actually work. Let me not trade it. He push. I do skip. Hmm. I'm fine with. Wow. So now he have to leave the territory. Hmm. But I want. Just switching. You are using Arch, by the way. This awesome WM. Yes, I am not using Arch, by the way, and I am using Ubuntu, but yeah, this is awesome WM. I want to trade the rooks. Uh, I had some problem with Arch Linux in past. The reason is I updated some of the package and the whole thing broke, and I wanted to uh, use my operating system for doing some project, and I had to do some reinstallation. And I was like, okay, I'm done. I need stability. I have got my tech stack. I need Tmux. I need awesome WM. I need Vim. Okay. At some point, I need to do some kind of pawn breaks, but currently this pawn is really weak, so yeah. And at any point he might plan to do that. Yes, stability and tested software is needed. Can't be bleeding edge all the time. For sure, man, for sure. Arch was really good. I actually loved Pac-Man package manager, but after that, uh, yeah, I need to work on my personal projects like RSSTL and other things. At that time, I don't know what I was working on, so I left Arch. I just needed a tiling window manager, my NeoVim, and yeah, that was good enough for me. I think I want to trap, like, somehow push my pawns forward towards his knights so that. Wow. He cannot take because I can take, so, and yeah. We have to go back. So, what window manager do you use? I used to watch a lot of your vids on configuring new in Java and other stuff, or you has quite a bit of code as well. Great to see you again. How have you been? Your presentation today. Yeah, I was doing some videos. Wait a minute. Let me just finish the chess and then I can talk. Right? Mm, because I am low on time. I need to do something regarding that. He'd come back. He might do that, but yeah, I'm low on time. I want to chat, but currently, okay, he cannot do that. Yeah. He This is a pure blunder. So let me just punish him. I'm very low on time right now. And now I guess uh, he cannot go this way, and yeah, his he has no other option than to trade. Okay, I think I can still take, and unless I'm missing something, I could take, and yeah. And I would go here, save myself from check, and now this is the plan. Simply this is the plan. Okay. Oh, I'd like to keep my bishop open. Yeah, oh, I'm not focusing, Okay, not focusing. Like to chat. Yeah, it's fine to chat. Hello. Yeah, I'm currently low on time. I cannot just go and say a hello word. That's fine. Yeah, I blundered the whole game. But it's fine. It's fine. I am low on time. And then you can push the pawn, but stop the rook first. Yeah, I'm low on time. This is a lost game. I am not focusing. Anyways, I think I should resign this one. Joining back in 5 minutes. Let me answer my opponent. Yeah, now I can talk. If someone is here. So regarding NeoVim and Java, now I do not do Java. I am a full-time Rust programmer, at least for open source, and Swift programmer. Currently, I'm working on some projects that are going to be the part of Hilo programming language in future. And I still love Haskell, but I was not sure that immutability is the way to go, because the machine itself is mutable. Then that's why I was working on this mutable value semantic thing, and Hilo is going in the right direction as well as Rust. Good game, thank you. And you graduated IIT. I was in Triple IT, and yeah, how are you all doing? So it's great to see that actually someone watched those Haskell things. I was doing those videos when I was in college time, so yep. I think yeah, if you guys want to talk about my projects I'm doing currently and how is my thing right now, the open source and all, because the time I was making videos I was working with NeoVim community, but now I have switched to many other things. Like first I went to C++ community, and then I am carrying forward my own project. Yeah. What's the biggest project we do? I The biggest project I did. There are some open source contributions that were really great. So I think I can talk a little bit about my projects. So I do not maintain this thing right now. At that time, I think I maintained it for like a month or two. This is this was a plugin for NeoVim, and yeah. What is Hilo? Yeah, I can talk about Hilo. Uh, After that, yep. The second thing I worked, yeah. Let me talk about all the projects. Let me talk about all the projects. So, the second thing I worked after this was, and I think this was good. Facebook experimental. This was libunifex. So libunifex is a Facebook project, and this is going to be the part of C++26, and I got to be some top uh, 10 or some contributor in there. It has been time I contributed to libunifex, so it's a structured concurrency thing. It's a really great thing if someone is interested in. So yeah, that was the thing I did after I left NeoVim community. And yeah, after that I contributed a little to um, NVIDIA StatExec. So this is again a structured concurrency implementation and going to be the part of C++26. The same person, Eric Niebler, is maintaining this, and my current teammate Lucian is also a contributor to this project. So regarding this one, I contributed a libdispatch scheduler recently, I think 1 and 5 years back. Wow. Yep. So this is how I started for libdispatch. Okay, and yeah, this was a really nice contribution to have, and this was a byproduct of my original project mraylib, and that is this one. Yeah. So mraylib is a ray tracer, and basically this is execution agnostic ray tracer. So what you can do is you can say that I want to execute this ray tracing algorithm, let's say on thread pool. It would execute it on thread pool. You want to say I want to execute it on libdispatch scheduler, it would execute it on libdispatch scheduler. Or you want to say I want to execute it on a GPU, and it will do that. Then why do you stop making videos? I got busy. Like videos for NeoVim are really popular, but after that I needed to learn a lot. After doing NVMLSP utils, I realized that I'm really bad at writing programs, and I need to learn how to write programs. So I did some uh, training on how to write programs. I wrote so many programs, and you can say mraylib is one of those things. This author of C++20 ranges tweeted about that this is a really great project, and everyone should look into it. I think author of stat format have also started this one, this project. And then currently I am working on two things. One is RSSTL. You can run this process on thread in a scheduler, basically anywhere. Yeah, basically you can run mraylib anywhere. The only thing is it should be a scheduler, and scheduler should follow us the C++20 concept scheduler. That means it should have a schedule method, and that's it. And that schedule method should return a something called sender. So I can go in technical details of that. That was a really great project. Currently, I'm working on this project RSSTL. This is my ongoing project. Currently, yeah, only few people know about this project, but the good thing is Dave Abrahams is working with me on this project. So if you guys do not know about Dave, you should know about him. Dave Abrahams is principal designer of Swift language. He's the creator of Swift standard library, and he is the creator of Hilo programming language for sure. And other things is, if you know about move semantics in C++, he has contributed that to C++. So really a great guy, a legend, and he actually helped me to get this project to a very mature state. And now we are expecting that in upcoming year we can try to propose this project as a part of Rust standard library. So that is the goal of this project. Other thing that is I'm currently also involved in is standard template library in Rust. Yes. So that was how I started with that. So that was the goal. I actually love STL algorithms, and to be honest, I was learning Rust and I wanted to use Rust because the language is good, but STL was not there, and Rust iterators are not that great to work with when you have algorithms that need multi-pass collections, right? So we need something like that. So I decided to do that thing for myself. So I started this project as my personal project, just for my personal use. But after doing this project for like 5 to 10 days, I realized that this project has really great potential. And then Dave Abrahams joined me in the project. So yeah, you can realize the potential of the project. Other thing I can talk about is my work on positionless Swift thing in Hilo standard library. So HiloLang. HiloLang is a language. We are currently working at Adobe, and there are Dave Abrahams is the creator of that. Dimi Rekardon is there. Lucian, Ambrose are the other people who do the development on the regular basis. I am working on the standard library front. So this is HiloLang. Yeah. So Dave asked me if I should join Hilo group and help them develop the standard library because RSSTL was going in a great direction. And currently we are doing this experimental project. So yeah, if I talk about it, even this is very experimental, like all of these are experimental. So I am working on a design of collections that does not need location of the element, and location of the element you can describe using iterator, or location of the element you can describe using index of that, right? And RSSTL went for the index approach, but in this one we are actually thinking that for designing a collection that actually supports parallelism a lot, you need to get away with location thing. And yeah, this is all the idea. I can actually talk about this thing. This is an ongoing thing. There are so many challenges, and I do 2 weekly meetings with Dave, and we discuss the progress on this one and other Hilo things with, of course, other Hilo developers too. So yeah, this is a long-term goal: RSSTL for Rust standard library and positionless Swift for ultimately in Hilo. So if it goes into Hilo, really it would be great, because that would be an innovation after like decades, right? Because I remember STL and other similar things actually care about the location of element, and this is the first time we are saying that there exists some higher order algebra, and we do not need location of the element to work with collections, at least for uh, till bidirectional collection. For random access we might want to have positions, but yeah, currently we are exploring that. So yep, I do not understand anything, but it sounds cool. I can talk in detail what part you want to understand, but yeah, this is kind of 7 to 8 months of work, so it might not be possible to understand, like tell about this in 5 to 10 minutes, especially on this chess stream. So yeah, it is actually cool. If you want, you can uh, see the HaloLang. I think we are seeing this as a successor of Rust programming language, and you'd be surprised that the creator of Rust is actually uh, posted about this thing that Hilo is the language he wanted to create, but he could not escape the complexity. And yeah, I think we are on the right direction. I may go over your commits. Okay. I think there is one more thing we should see, and I think if anyone is also interested in Rust, they can try doing things with RSSTL too. Dave is also there, and RSSTL and Hilo are going in parallel. So you can see like in the RSSTL being mentioned in Hilo, and Hilo being mentioned RSSTL, because the goals are really overlapping. But yeah, what comments you want me to go over? You want me to go over the positionless design thing? So let me try that. Repositories. Where is? Yes. hmm Yes, please. Okay. I think I can merge this one right now, but I do not want. I, I would wait for a little bit of approval. Anyways, yeah. Collection.swift. Okay. So here is the logic that we have a protocol collection, and collection is basically linear sequence of elements, and now a collection have an associated type element. Okay, and a collection can project two kind of things. First kind of thing is a subsequence, and that is a slice. We usually think it of in terms of sub array or something. Okay, and other thing is partitioning. So partitioning is like dividing collections into slices, but those slices are contiguous and disjoint, right? So that is the overall idea. Okay, and if I talk a little bit about it, let me open GIMP. Mm, yep. So if I talk a little bit about it, let's say I have an array like that. Okay, uh, so a slice is any subsequence. This is a slice, right? Any subsequence. So we can project a slice out of a collection. That is the first thing we are saying. And the second thing we are saying is, what I can do is I can divide this collection into slices, and those slices are contiguous in nature, right? Why is this a basic property because if you think about it, if you can project multiple contiguous slices out of a collection, then you can use these slices in different threads and without using any locks, right? So this is really great for concurrency because uh, you do not need locks. This is a purely parallel way of thinking collections, right? Otherwise, if you would share collection and you'd have locks around that, it's a mess. You are not doing any parallelism. So this is a concurrency first design for collections. Now what we say is, with a slice that is a sub collection, what you can do is you can just drop the first element. And currently I am talking about the capability of collection where you can only go forward, you cannot go backward, or you cannot do random access. Okay, you can only go forward. So if that is the case, then a slice can only drop the first element, and dropping the first element is not actually popping the element, it's just not having that element in the slice. That's it, right? And regarding partitioning, we can have a partition count as a property. We can project parts, of course, because, and the parts here is the subsequent thing, right? The slices that, and we can actually also project a single slice out of it, right? A single part. Other thing is, now we need a primitive for actually growing things, right? And for that, for doing the traversal, we need this kind of abstraction like grow. Okay, and what it does, it basically grows a part. And oh, what was that? Wow. I do not know how to zoom out. Maybe something like 100. Yeah, even not 100, 66 for 7. Yep. So when I'm saying that, what I'm saying is this part would grow and the next part would actually shrink. And because collection has a way to get the first element, you can get the first element of the other part, and this is how you can traverse the whole thing using parts, right? And then there are other things like transfer all elements to prevent transfer all elements to next. These things are important if you start thinking about algorithms like strut rotate. So yeah, this is the thing. All the rest must shrink, and this all must be parallel, so you must be using shared pool or something. So okay, let me first answer all the rest must shrink, not all the rest, the next one. So for example, if I grow part 0, then part 1 must shrink, right? And that means the precondition is the part 1 should not be empty. That is the contract, right? So that is the first thing. The other parts are not affected. So if you think about it, you can start with two parts. First part is empty and second part contains the full thing, and then you can grow this part, right, and access the first element of this one. You can grow this part again, access the first element of this one, and by this way you can do the traversal. And all of this must be parallel. Regarding parallelism, uh, the parallelism is not encoded in the collection, but the design is as such that it can be used in a parallel way, because like thread should not be a notion, thread or any concurrency thing should not be a notion of collection, according to me, right? They are two separate things. Collections are regarding the storage of data, and threads and other things are regarding execution of things, right? So they are having separate concerns, and that is why the design is just as such that you can use this design to actually develop highly parallel applications. And that is by saying that uh, my claim is every collection has this notion of segmentation, right? And that segmentation is what we are calling partitioning. Other thing is we have also integrated Matt Austin segmented iterators thing. So I don't know if it's present here. Yeah, this is there. So segmented collections. So it might be possible that you have things like vector of vectors, right? And now if you want to traverse vector of vectors using one iterator, that is not the right way to do that, because of course there would be some conditionals and it would be slower than doing the two loops. And that is why we need to have some way to say that the collection is inherently segmented. So that is another thing, uh, yeah, I have worked on. So yeah, this is something I am doing in positionless Swift. I can even talk about more like bidirectional collection and random access collection, and there are other research topics we have for this Tuesday or Thursday meeting, uh, where we talk about should there be a notion of mutable slices as well as immutable slices, like they should be different entities or they should be same entities, right? So yeah. Damn, what is the biggest challenge you are facing in this one? What is the biggest challenge? So the first challenge was uh, actually even thinking that this can be a thing, right? Because historically collections were really based on locations, like iterators and all those things are very location based, right? If you think about C++ iterators, they are generalization of pointers, as well as if you think about indexes, they are generalization of okay, positions, they are generalization of indexes, right? But so that was first thing, was POC of this whole thing, uh, was itself a challenging one. Other thing currently I am facing is incorporating mutation model in the project, right? So I can talk about let's say some algorithms, let's say rotate algorithm, right? So if we see the rotate algorithm, many times we need to project slices and partitioning, like this is additional partitionings, right? And when we project partitioning, we have this challenge that that partitioning should have mutability inherent in the type, or mutation is something a different thing and it should not be the part of the type itself or the protocol itself. So yeah, that is the thing. And this rotate algorithm was really hard to write. If I think I can share some Hilo Slack discussions, because we are doing it as an open source thing, right? So okay, yeah, uh, we do not have older messages. So in the older messages, we were actually talking, okay, why rotate is a really hard problem to do with this design, right? And I think Dave Abrahams have written a really great uh, documentation that why this rotate was really hard. But then I came up with, we can have because in starting we were thinking that it's fine to actually break a collection into two slices, but then I realized that that is not the case and we need a quadrisection or trisection or a bisection as needed. For rotate we needed quadrisection. So yeah, that was the case. Sequential, totally sequential, I do not understand what is the sequential thing, so can you explain that? But yeah, this is something I'm working on. That is why I needed a stability, and I left Arch Linux. Hmm. If we have no more questions, we can uh, follow the chess then. Yeah, you have been disconnected. When you were talking about how precisely we treated collections. Yes. So wait a minute. Yeah. So previously, yeah, when we used to treat collections, we just have this notion of location, and the problem with this thing is when you talk about location of the elements, then the type system does not know that this location and this location, okay, are in different parts. So many times when we share things around two threads in languages like Rust where you cannot do that, it's just not possible, right? Because type system does not know that these two positions are really different and two threads are going to operate on different region of the collection. So we needed a way to convey to the type system that yeah, they are two different things. They are just two different memory regions, and that is why segmentation is, yeah, a parallel thing, and the old model was inherently sequential. So you are right. I am right here with you. I'm right here with you, bro. Exactly. Thank you. Thank you. Yeah. And uh, I really appreciate that people are actually agreeing on this one, because I think when we will take this thing to the standard library, other than high-level people, rest of world would have problem initially, because this is something no one have seen before, and I think it would be hard to convey to uh, other communities. But that is why for RSSTL we are going with the position model, because in Rust, even doing this thing is really hard due to lifetime calculus of Rust. I can talk about that. Rotate sounds like a really hard problem. Rotate is a really hard problem. Rotate is a really hard problem. So if I don't know if you know about rotate. So let me say Rust is immutable too. Rust is not immutable. Rust you can have mutations. It's just that there cannot be two mutable owners of the same thing. So two things cannot mutate one thing, right? So let's say I have an object O, two things cannot mutate O, and that is really great, because if one thing mutates O, then other thing should uh, not see that effect, right? Otherwise, it would be a surprise for the other thing that what exactly happened. I did not do anything. So yeah, I can actually talk about this one, like this philosophy of two things cannot mutate one thing. There is a really great example by Dave. Uh, but this rotate is a part of C++ standard library, original C++ 98 algorithm. So we have a really good implementation here, but this implementation again is iterator based. So doing this here was really easy, but taking it to positionless design was, oh my goodness, I will have to say it took me 10 days to figure out uh, what exactly is the structure of the whole problem, because positionless design is really structured way of programming. It goes in that extra way. So yeah, I can talk about the Rust philosophy of mutation if you want. So what is my goal? Why I'm streaming is I want to stream for Advent of Code. Yep, on security standpoint, it sounds great. No, that how it should be. Yes, and even for correctness point of view, it is the same. So if let's say I talk about it, okay, uh, something even wow, uh, bad mutation.cpp, right? So if I really talk, wow, this is hash include. Let me have IOStream here, right? And I have a function named increment by n, and what it does is it increments x by n, right? It increments x by n. Then what this function can do is it can do x plus equal to n, and that is good enough, right? But now using our function composition logic, what I can say, increment by 2n function is there, right? And I can say I can just call increment by n two times and it should increment by 2n, right? That is how we think about function composition. And this program really seems to be really correct, right? Uh, and then I start writing it like, okay, int x equal to 3, or let's say, yeah, 3, and I do increment by 2n, and I pass x comma x, right? And suddenly this program stops working, like this program breaks. Now this is how we think about function composition, right? For function composition we think about it like, okay, increment by 2n can be composed using increment by 2. So we increment by n two times, that is increment by 2n. But now this is not the case, right? So if I do uh, x, what I expect it to be 9, right? But if I compile the program, uh, it is 12 and the whole thing breaks. So why it is breaking here is how we inherently think as a human is x and n are two independent entities. This is how we think about it, right? And when we think about x and n to be two independent entities, then only we can reason about the things, and then only we can write correct programs. So anytime what we can do is we can just pass n by value and the whole thing would start making sense again, right? Because that value is independent. So that was the, you know, intuition that there should be only one mutable owner of an object. And when we passed x comma x and n was a reference, there were actually two mutable owners, right? Because in here there was a mutable owner as well as an immutable owner, but yeah, that is should also not be allowed. So that is the Rust philosophy, that Rust does not compile this program. Rust says that when you do this call increment by 2n, it would just not work. It would simply not work. It would simply not compile. So you have to explicitly say x.clone in Rust. So yeah, that was the philosophy. That is the Rust philosophy of mutation, and that is very similar philosophy for Hilo. And I agree with all of this. I used to agree with all of this, that this is the right way, and this same with Swift. So yeah. So if you want to write correct programs, we have to uh, just follow the same model. Also, that is why I claim object oriented is not the right way to write programs. But yeah, we can discuss all of those later. Should I send him a rematch or something? It was nice talking to more people on the stream. Let's see if he accepts the rematch. Okay. Oh my god. So in the first one they okay, let me cancel the rematch. I am more interested in code. Oh my god. So in the first one they took the actual pointer. So in the increment by n it took 3, added 3. So now you have 6. In the second and 3 should have been 9, but it returned 12. Exactly. Right. This is exactly what happened. So what happened is this function incremented x by n, right? But now n is also a reference to x only, so n itself got increased, right? And now this thing incremented x, the current value of x, by that incremented value of n, right? And this is what happened. Like, we were really thinking that x and n were independent, and that is why we were able to do this function composition. But now we cannot do that because x and n cannot be independent. So when I even write the programs in C++, that is something precondition for me, and that's an implicit precondition that do not do these kind of stuffs. Do not do that, right? So you might have realized how hard it is to write correct programs using C++, right? And in the C++, you can always have this model, right? You can always do pass by value and everything just works. But in languages like Java, you do not have alternative, so you do not have basically a way to write correct programs at all. So without independence of two variables, you cannot think about their mutation at all, because our brain is not made for such thing. And even AI cannot reason about it. AI would claim that this code is correct without those independence precondition, and then we'll give him this thing, and they would be like, "Oh, I did the mistake." So, is there anything else you want to talk about? So, how are you doing? I think I was making videos like 4 or 5 years back, so it might have been a change for in your life too, right? What were you doing at that point, and what are you doing at this point in life? That is interesting to know. I think my opponent is not accepting the request, so yeah, I might want to end the stream now. I think I have streamed good enough for today. Not for today, I have to work on the positionless thing, but yeah, currently I have to eat something at least. Okay, so if yep, I was in college and I graduated now. I have a basic software development job. That is so nice to hear. That is so nice to hear. I was also in the college at that point. That is so nice to hear. How? So how is your job going? Are you lacking the job? And by any chance, do you use NeoVim or any other editor right now? And yeah, it's basic web dev, mobile dev job with a little cloud. That's nice. Yep, NeoVim all the way. Yeah, that's really nice. Even in my job, I also use NeoVim only because it's really hard to live without Vim motions. I really wanted to use like Linux in my work, but yeah, currently it was an honor talking to you and knowing about your work. Thank you for the explanation. I shall take your leave now. For sure, I also need to eat, and yeah, it was also great talking to you, Rudra. And I think I will do more and more streams. So if you'd be interested, we'll see you there. Anyways, I'm also leaving, and it's Janmashtami, so happy Janmashtami to everyone. Hare Krishna, and yeah, bye bye.